Hey everybody, this is Larry. This is July 18th, 2024 here in New York City. I'm doing an extra problem today. I mean, I think I technically did it before, but I don't know. I feel like some moments I have energy, some moments I don't. So I want to take advantage of the moments in which I have energy. And tomorrow I have kind of a not a tough day of workout, but it is still a kind of I don't know. It gets very tough. Friday is probably like the toughest day of workout for me, I think, because basically, not just because of Friday, but also all the days leading up to it, right? Like for example, today I did a long run of 12 miles. Tomorrow I'm supposed to do 5 sets of, not including warm up, 5 sets of bench, 5 sets of squats, and then about 3 sets of 7 accessories, and then maybe some mobility work on my just like my injuries and prehabbing and stuff like that. So that's like 3 hours of workout pretty much, especially if you count warming up and cool down, which I'm at that age where I have to do it. And then after that, I'm going to run like 8 miles. And keeping in mind, this is after 2 speed days and a long run day, right? So it's just I'm usually very mentally beaten by Friday. So today, I'm going to do an extra bonus question for y'all. So hopefully it's not too bad and just kind of see where this takes me. Okay, so today we have 1121 divide array into increasing subsequences. Given an integer array num sorted in non-decreasing order in an integer k, return true if this array can be divided into one or more disjoint increasing subsequence of length at least k, or false otherwise. Okay, what does that mean? Okay, let me actually say. Given an integer, let me drink some water too. Given an integer array num, okay, so this is not an integer k. Return true if this. Okay. One or more disjoint. Okay. Wow, why is there 5 hints? But okay. So I see what the problem is. I guess the idea here is that some numbers can be on not duplicates, right? But I think greedy works, right? Yeah, I mean, I think either is greedy. Yeah, I think greedy works. I mean, you have to be careful, but the reason why it works is because I feel like every decision, there's no real decisions. Every decisions should be forced if you're careful, right? Meaning, like I guess if you have something like 1, 2, 3, 3, 4, 5, or something like this, and k is equal to 3 or something, then you're kind of like maybe forced. I don't know. And of course, if you have something like I don't know. I don't even know. Maybe is this the only weird case? Right? But even that, like you can rejiggle stuff, right? Like so I'm trying to think whether this is true in a greedy way. I mean, so okay. So one observation that I almost want to say should be true, but maybe I'm wrong on this, is that okay. So I think the idea is that okay. So I think the first idea that I have is that the max number of these like the only place where you have to split them up is of course if they have the same number, right? Because here then you cannot split in two subsequence. If you have two threes or you have three threes, then you need at least three arrays, right? Okay. I mean, I think that part is easy to reason, right? So I'm not going deep into that much. And then the other thing is that other than this properly, everything else kind of just almost doesn't matter where they belong, right? In a way, because you know that you know 3 is taken. So I mean, yeah, maybe they have to be increasing, but it doesn't even matter because everything is like it doesn't have to be increasing order as long as they're just unique, right? Like in some order. I mean, if you process them from left to right, they'll be increasing. But so then, like, you can create in this particular case, you could create 3 arrays, and then it really doesn't even matter what everything else is, right? So here you have 4, 5, or something like this, and then just kind of start filling them out. I mean, you probably don't. I don't even know if you need to kind of like manually do it, right? And of course, in this case, you just ran out. But if you have too many, that's fine too, right? For example, you have like 6, 7, 8, 9, 10, or even if you are lazy with your algorithm, you have 6, 7, 8, 9, 10. Then you can just, like by definition, just move 2 of these things over and then just jiggle it so that they all have at least k elements. So that part, I don't even think it's that. So I think that's the general idea. I don't know if there's any, yeah, so I don't know if there's any edge case that I'm really missing, because the order doesn't matter. I mean, there is some stuff about increasing, but you don't have to insert them in order, because then you could, if you insert them in any order and then sort them later, right? It doesn't, because so all the subsequences are going to be increasing because this is already sorted. So then now, I think if you just allocate stuff, like if you allocate stuff, if you just allocate stuff one by one, I think that should be okay. And there may be even some shortcuts if you really like, but yeah. So okay, so K we want to say maybe, let's just say yeah, actually K doesn't matter. So what we want to do is collections.counter, right? We put everything in a frequency table. Or, I mean, K mattered, but not yet, right? And then here, we want to say the max value, right? Max f dot values. So then now, this is the number of partitions that we have to make, right? So maybe we just call them partitions to go to this. And by definition, like nothing should overlap, right? But just by, I don't think it's pigeonhole, but it's just like, but I think maybe you can, because that means that the max, yeah, right? So then now all we need is just and you could do it the dumb way, or you could maybe even do it in a smarter way if you want, which is that now we have f dot values, and maybe I did a max, but we can actually we don't even care about the numbers really. So we just want f dot values, we sorted it, right? And maybe let's just say we sort it and then we reverse it. So then here we have just values, and then here the partition is just going to be v sub 0, right? The first element, because it's already sorted, reverted. And then now we just do the math, right, of how it can fill. So now, I mean, in a way, and do you even need to? Because then now, like if you kind of, the way that I'm thinking about it is that, okay, let's say you have values and you have duplicate numbers. So because we're putting them in this order, let's say we have someone like this, and then maybe we have an extra 2, we have an extra 4. So if you look at just the values, there's going to be 3 3s, 2 2s, 2 4s, right? And we just want to do the 3s first. And here you're just kind of putting them like one by one, right? So it's going to be 3 3 3, and then you can fill this out with 2 2, and then 4 4, and then just order 1 5 or whatever, right? So that means that partition is going to be just this number, and you could kind of fill it out, but you already know how many numbers you have. That means that we want to I don't know, am I missing a case? It feels like this. So basically this is the number of partitions, right? And then the smallest array is just going to be this divided by partitions. So n is the number of numbers, right? The total number of numbers, or the sum of the values or whatever, but right? So then now n divided by this, I have to figure out if I want to round up or round down. I think round down makes sense actually, because that's the smallest one, is going to be greater than or equal to k, right? Is it this easy, or am I just being dumb? Like I feel like this seems too simple, and of course there's some optimization now that we have this, like you don't have to get sorted anymore, you would just get the max, right? So then like, and we'll go back to value max, right? So we don't even need the other thing technically, but I was thinking about simulating it, but then I was like, maybe I don't need to. I don't know if this is right, to be honest. I mean, this is like a constructive argument, and I don't know if I'm missing a thing. So let's give it a YOLO submit, and maybe if I'm wrong, then at least I learned a little bit. Okay, wow. I mean, yeah, like I said, I don't. I mean, like I said, this is more of a the code is very. It's one of those things where you look at the code and you're like, okay, what did Larry did here? But if you watch the video and obviously and thinking about further explanations, this is not that bad, right? I mean, you look at the code and and also it's one of those things where you look at the code and maybe like you convince yourself you understand it, but you don't really, like, until you really dig into it, it's, the code doesn't tell you enough. But I think that's the idea, right? Is that the max element is just going to be the choking point, and then everything else is just you fill it in. And I actually really did thought about simulating this filling in, and I was just like, well, if you fill in there evenly, then there's really no algorithm. So then that's why you can do this this thing to calculate, because there's n total elements. So that means that you know what the smallest stack is going to be, where it ends, and so that's how I kind of came up with this. And apparently it's faster than 100%. As a result, which is actually pretty nice, because this is an older problem, right? So 100% is actually a big amount. Is there any other crazy algorithms that one space, huh? I guess you could do all of one space just by I mean, I was a little bit lazy with the counter. The other, you could just do all of one space by noticing that, well, this is sorted, so order like getting this is just looking at adjacent values, right? So that'll be all of one space. That's a fair point. I didn't even think about optimizing that to be honest. But in general, honestly, I never think about optimizing all of n space to all of one space in general, unless I see it randomly, just because it's not necessary usually. I mean, on an interview, I guess if someone asked, it seems like probably everyone's doing it the same way. How does this avoid overflow? I mean, I think it handles underflow, but I think it yeah. But yeah, I mean, I did minus O of n time, O of n space due to this counter, but like the comment said, you could reduce this to O of one space just by counting adjacent things, because it's already sorted. I was just a little bit lazy, and also, to be honest, I was thinking about, like, you saw my process. I was thinking about simulating this, and then I just was like, oh, maybe I don't need to. But then you also saw me like having doubts, because this looks too ridiculous for a hard bit. But I guess this is an older thing. I don't know. Anyway, that's all I have for today. That's all I have for this one. That's all I have for the bonus one. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.